Hi, everyone. It's nice to be here. So, thank you for the introduction and for the cheer. I'm Regan Mandryk. Oh, there we go. And I'm a professor in computer science at the University of Saskatchewan. Yeah, thanks for the woo for that, too. I know. Come on, half of you nerds went through there, didn't you? Come on. All right. So that's where I'm a professor. I'm a professor of HCI, which is human-computer interaction. But my research area is all focused on computer games. And so for the last, oh God, it's been too long now. I guess it's 10 years, 10 years. That's what I've been working on, is trying to do serious research on the topic of computer games. Oh, it has been 10 years. I actually just, is Phil still here? I saw Phil in the back, and I realized that when I started at the university, I used to go buy Slurpees from Phil at the Cove. That's how long I've been there. Yeah, so it's been a while. Anyways, so what I wanted to talk to you a little bit about today is the kind of work that I do. I wanted to tell you a little bit about the stuff that's going on in my lab. When I say I, at any point in the next 15 minutes, I actually mean we, because this is the work that I've done with my large group of students that have gone through and are still there. Okay, and also today is the CS banquet, so I know, CS grad banquet, so I know that a lot of you people who are graduating this year will be leaving in the next few minutes. Most of you have heard this already, so. Okay, so this is a little bit of an overview of the kind of work that I do in the area of games research. Okay, so I'm gonna go through these in a little bit. Okay, so this is where I started. So back a long time ago, I was a Ph.D. student at Simon Fraser University in Vancouver, and electronic arts sponsored my dissertation work, which was really about, can we find out how much fun people are having when they're playing a computer game? Because if we can find out how much fun they're having when they're playing a computer game, then we can maybe do a better job of developing games that are fun and not developing games that aren't fun. So they wanted to find out if we could basically find an objective way of measuring fun. So what I did was I basically hooked people up to physiological sensors, much like you see in a lie detector, for example. I would run a lot of mathematical models on that to see if we could build a model of whether or not people were having fun, whether they were frustrated, whether they were excited, what was their gameplay experience. And of course I used hockey, because this is Canada, and also it was 2003. And people were hooked up to these sensors, and I built these mathematical models of people playing games. And so that was kind of where I got into the whole area of games research. Before that, I was doing modeling of people's interactions in virtual reality and other types of mathematical modeling. And so this is really my first introduction into the world of computer games. So, where's the clicky guy? I can't click my own videos, can I? Thanks. So that led into an area I was using, oh no, sorry, it's a video, so you might just have to, yeah, thanks. Okay, so that led into the area of using physiological sensors, not as an evaluator of computer games, but as an input to a computer game. So this is an example of an EEG sensor, so it measures kind of brain activity. And what we did in this project is we had, the EEG activity was measured, and then we used that to draw graphics on top of any running application. So in this case, you can see as the player gets more excited, more and more spiders start crawling across the screen, and making it harder and harder to play. And so we actually used this, we made the system such that you could import any graphics in, so that it would kind of look like it was part of the game. So we had like a fiery portal over World of Warcraft. We had frost coming in over NHL because hockey, because Canada. We had water droplets over kind of a spearfishing game. So we had graphics that kind of looked like we had cracked glass over Portal. It was all using different kinds of pixel shaders, and it made it look like the graphics were part of the underlying game system. And this was designed to ask questions about how we could actually use our body's reaction to computer games as a way of input into a computer game. So not just the traditional controllers, but can we use our bodily reactions? So if we're playing like a Harry Potter game and we need to like sneak past a sentry, can we actually use our breathing activity? So you actually have to regulate your breathing activity so that you don't alert the the sentry that's standing there, for example. And we also use this system in a more clinical context, which was really about, can we help kids with fetal alcohol spectrum disorder, which has very similar symptoms to ADHD, can we help them learn to self-regulate their focus? So we deployed this with a bunch of kids out in British Columbia for 24 weeks. And what we found was that it was very helpful. They played computer games for 12 weeks, and through this technology learned to self-regulate their attention a bit better over that 12-week period. So it had clinical applications, which really led into my area of research, which is about games for health. This is also a video. Sorry. So a lot of the work that I've done in Games for Health has been about how we can use games to help motivate people to exercise or make healthy eating choices, or basically get out there in the world. And this is a huge part of the research that I did in the first 5 years that I was a professor at the university. And this particular example is a game that we developed to use the wheelchair as an input device, using the Microsoft Kinect as a sensor, so that people who are in wheelchairs could actually play Dance Dance Revolution with an able-bodied competitor. And so we looked at different, although we created the technology that allowed them to actually use their wheelchair as an input device, we also looked at different balancing mechanisms. So how can we balance games so that people don't feel like they're getting an unfair advantage from using an input device that's maybe not as high fidelity, but that they would actually be able to be competitive in the same context. And so we did some work on that. Oh, this is also a video. You're gonna get this a lot. And so this, there's a whole line of work also that we're doing in the lab that's about collaborative games. And a lot of people talk about how games are played by people in their basement, sitting alone. It's very socially isolating. There's this whole stereotype around what a gamer is like. And first of all, that's kind of not true. From the last couple of years actually, but more recently in the last 2 years, co-op mode has been the biggest kind of draw for a lot of games out there. But we're also creating collaborative games that help people connect to each other. So how do we help people form relationships, maintain relationships using collaborative games? So this is an example of a game that we developed to help distributed teams build trust. So one of the things that's going on nowadays is that people are not always working co-located in the same location. Sometimes you have people that are part of your development team that live in a different city. And one of the things that's really important for working together as a team is being able to build trust. So trust is really important for effective teamwork. And so how do we help you build trust? Well, the whole, like, if you've ever watched a movie about trust building, you'll have seen, you know, the whole trust building movie montage thing where you have trust falls and like ropes courses. And I don't know, I've seen Pitch Perfect too. No, it's not really this audience. Okay, all right. Maybe other movies have. Anyways, so you have lots of ways of building trust when you're together in the same room, but you don't have a lot of ways of building trust between strangers online. But one of those things that you can do is actually people can play games together. So we're actually looking at different game mechanics and separating, kind of teasing out which of those game mechanics was best for building trust. This was a game that was based on a German board game called Labyrinth. That was the first game we did with this in mind. And we actually found that this game was better at building trust among two strangers online than the typical approach, which is answering icebreaker questions, which relies on personal information exchange. Things like, what topping do you like on your pizza? Or if you were to choose between a mountain holiday or a beach holiday, what would you choose? And those are kind of the typical ways that people build trust online. But as you can imagine, if you're introverted, if you're not really an agreeable person, if you're not really enjoying the conversation, those techniques don't really work very well. And so you find that kind of for those people, they don't really work very well. But for games, it worked well for everyone, so it was a good approach. We also do work on helping foster relationships. So I've done work on helping distributed families stay in contact. So some work with Microsoft that I did was on helping preschool-aged children, pre-literate children, communicate with their grandparents who lived in a different city. So when you want to get to know a kid, you don't actually sit down and have like a Skype conversation with them. When you want to get to know a kid, you actually play with them, you read a book with them, you're silly with them, and that's hard to do in an online context. So we started creating games to help distributed grandparents and grandchildren interact with each other in an online context, and that was sponsored by Microsoft Research in collaboration with Sesame Street. And we've been working on also helping distributed people who are in distributed relationships, so couples who don't happen to live in the same city, try and share activities through games. Okay, so another area that we're really big on is the area of games for science. And so this is where we use games to collect data for other areas of science. And it sort of started in helping basically gather a lot of data in the context of psychology. So I don't know how many of you took an intro psych class. Yeah? Okay. But you had to probably participate in an experiment pool. So you had to go in for credit. You had to sit down and do some sort of experiment. And so that's one way of gathering data, but another way of gathering a lot of data is by basically having people play games and kind of gathering data implicitly. And so we started creating games whereby we could study effects on human behavior or human cognition or how attention is distributed. And so we started doing that in the context of psychology, but we've also been expanding that into the context of, for example, water science or how plant breeding works. And so we've been doing a lot of games that have been developed to gather data so that we can make scientific advances in other fields. And along those, and the flip side of that, and this is probably, I would say, a large percentage of my work, probably 30%, is the science of games. So this is really about understanding why people play. Why do people play so many games? What motivates them? What draws them to a game in the first place? Why are you attracted to play whatever game it is that you're, Counter-Strike, for example. Why are you drawn to play that game? And then once you're there, what keeps you there? What aspects of game design actually keep you playing, not just in the short term, but in the long term? And what kind of mechanics in those games help transition players from that short-term play into that long-term play? So we have a real advantage in this area internationally because a lot of the kinds of people who study the science of games are actually doing this from a social science perspective. So they're psychologists or sociologists, mostly media psychologists, who are using off-the-shelf games to try and understand why do people play games? What draws them to them and what keeps them there? But we're, of course, a team of mostly computer scientists, so we can actually kind of tease out some of the subtle nuances that other people can't by creating our own games and then manipulating little aspects of them and seeing how people respond. And so this has given us a little bit of an advantage in terms of trying to understand what it is about play that's so thrilling and how that differs between different types of players. So mostly that kind of stuff is the kind of academic research questions that we've been asking. This is the type of research that we do experiments on, or we publish on in academic conferences. But we also work a lot with industrial partners. And so the kind of work that we do on an area called games user research, which we'll talk a little bit about, is really about how can we help game developers create better games. So this goes right around full circle to where I started in this field, which was trying to help electronic arts understand what makes games fun. So if we kind of understand the science of games, we can then apply that to development processes. So how can we help game developers build games that are more fun? And so we work with lots of different companies. This is a German company that we worked with, and then this is a screenshot from Apotheon from Alien Trap, which started here in Saskatoon, but moved to Toronto. And so we do a lot of work with small game companies like Alien Trap, and I'll show our industrial partners later. And we do a lot of work with big companies. And we do work with the companies that own the big companies, which has been really exciting. So you guys have heard of Riot, make a game called League of Legends, and yeah, I like the woos, it's nice. And there's a company that owns Riot called Tencent Games. Who's heard of Tencent Games? Anyone? Oh, a couple of you. Nice. So we've been working with them, and Max, who's a Ph.D. student in my lab, just got back from an internship at Tencent Games in Shenzhen, where we were working with them on doing some very interesting localization research. So we work with all sorts of different companies, the biggest companies. Tencent is probably the biggest game company in the world, through to companies that are, one or two people that have an idea and a passion for building games and want to do something great. Okay, so that's what I do. So why does everything that I do have to do with games? Well, there's a lot of reasons. Number one is this is a little bit of some stats on the Canadian game industry. So we're actually really great in Canada. I don't know if you know this. I've told this to my poor students, some of you who have heard this a couple of times now, sorry. I've taken a couple of my classes this year. I thought you'd be at the grad banquet by now, man. What are you doing? So sorry you've heard this before, but we're actually the third largest producer, Canada is, of video games in the world after the US and Japan. And you can, yeah, nice. Nice. And you can consider we're really batting well above our weight, given that they have some really big names in those countries. So we're doing pretty well. And 54% of our companies, game companies, self-identify as indie. So we have a lot of small studios who are coming up. So that's one of the reasons why I do this work, because I think Canada, we're a hotbed of video game companies. And another reason that I do this work is because people like to play games. So I don't know if you know this, but like I think it's 94% of girls and 97% of boys under the age of 18 report playing games on a regular basis. And they play a lot of games. They rack up almost as many hours playing games as they do in school, in middle school and high school, sorry, not in elementary school, which is kind of crazy, but people are playing a lot of games. And so normally this is the point when I would be talking to people and I'd be saying, oh, games are really important in Canada for our economy and people are playing a lot of them, so you should really fund my research or you should really publish my research. But you guys are all amenable to the idea of video games, so I'll just move on from there. And tell you that this is the biggest problem that's facing us in terms of how to do serious science on the topic of fun and games. And this is basically the idea that it's called the mundane realism, and it's like, how do you do kind of really controlled, hard, experimental science on something kind of as loose and as fun as games, where people are playing under their own volition? And so that's what we've sort of been dealing with, is how we do this type of work. And I see that the time is kind of passing here, so I'm not going to go into a lot of details on this, but I'll just kind of walk you very quickly through the different methodologies we use to do this. So we do things that are like really kind of qualitative, focused on interviews. For example, we looked at people studying how they value their characters in World of Warcraft. This is work done with Ian Livingston. Some of you guys know him here. Yeah, I like that. So how people value their characters in World of Warcraft, and you have to do kind of that really in-depth kind of interview work. We also do work on data mining and analytics. And so this is where you take lots of big data. You take data from studios and you try and figure out how people are playing games based on the analytics that you're gathering, all this data that game companies are logging already. This is a project that we did with Play OK, where we looked at people using games that had no chat. Sometimes we combine these methods together. So this is a project that Max started with a game company, looking at how players with different personality types played a game differently, and how we could actually predict that based on the types of actions they were doing within a game. And this is with a company called Eastside, who do a game called Pot Farm, which is a farming simulation game, but with a marijuana theme. And they're located in Vancouver. Of course, yeah. But sometimes you need to know a little bit more about your players than you can gather from a couple of surveys and some analytics. So we do a lot of lab experiments. This is Ph.D. student Matthew Miller, who's in the lab playing an extra game using the bike as input. So we do a lot of stuff in the lab as well, because sometimes you need sensors like a bike, or sometimes you need physiological sensors like in this example. But the majority of our experiments now are done online. So this is where we try and either recruit players that are players of a game, like we recruited Quake Live players for this game so that we could test how they navigated in different environments and what kind of cues would help them, and then we visualized that data. But we also gather data from people of all sorts of ages, generally through a platform called Amazon's Mechanical Turk, where we do online experiments. And finally, we've been moving sort of into this area of helping companies do very large testing, but of course this is like with games that are now done. So this isn't for games that are under development, this is for games that are done, so that you can actually do kind of this very traditional A/B testing with games. Okay, could you play, this is actually a video, I know it's surprising. If you want to know more, because I'm at the end, you can go to the website. So sad, this website, built like 8 years ago now. And you can filter by my name, and you'll see that this is the work that my students and I have done together over the last number of years. There's like 100 publications that are related to games. So if you're interested in any topic on games, there might be something in there for you, or you can feel free to email me to see if we've been working on a particular topic that's relevant to your interests. Last plug, because you know what? This is Vendasta, and you guys come into my house, and you steal all my best third years for your internship program. So frankly, I'd like to make a little plug for my master's and PhD program. Anyways, it's called Swagger, Saskatchewan Waterloo Games User Research Training Program. It's the first actual training program for graduate students to do games user research in Canada. So it's a collaboration between us and Waterloo, and we do training of master's and PhD students specifically in the area of games user research. So we train you to work in the video games industry, and we work with lots of industrial partners on this who have committed to providing students with internships and helping advise their progress as they go along. So with that, I'd like to say thank you for your attention.